Howdy, math humans. We are going to do 1.4b today. We're going to be talking more about our functions. Our objectives are that we're going to talk about domain, range, interval notation, and evaluating piecewise functions. Grammar is a bonus. All right, so let's start with domain. Domain is the x values of a function that are defined. Okay, we don't want to include those that are undefined, so it's the x values that are defined. The range, same thing, it's the y values that are defined. We don't include those that are undefined. Okay, we'll get onto this more and we'll do a couple of examples in just a moment. We're going to talk about interval notation before we do more on domain and range. So for our interval notation, this is the expectation for big kid math. All right? So no longer, occasionally we will do compound inequalities, but primarily, QU, that's a long word to spell, IES, we're going to do interval notation as our expectation. So remember that square brackets are called closed brackets, and that would be as if I had a number line and I had a closed circle, and that would mean that this value is included. Closed brackets mean that values are included, and by values I specifically mean the end point. Okay? All right, an open bracket is going to be very similar. It's going to be as if you had a number line and I have an open circle. So in this one, the end points are not included. And I guess to be consistent, I'm going to change values and I'm going to have that be endpoints because that's a little bit more specific. All right? So let's do a couple of examples on this. If I had the interval from 3 to 10, that's the same thing as saying 3 is less than or equal to x is less than or equal to 10. Alrighty, and notice that that means the 3 and the 10 are included because of the less than or equal to. If I had 4 to 7 with an open bracket, that means that 4 is included and the 7, notice there's no equal sign, the 7 would not be included. Okay, and then if I had maybe a 3, 10 this way, that would mean that the end points are not included. We can mix and match these a variety of different ways, but you just need to remember that square brackets means that the end point is included, and an open bracket means that the end point is not included. And I think about it like a closed circle and an open circle. All right, let's do our first example, and we're going to talk about domain and range. So it says find the domain and range. Okay, so I'm going to just give you a couple of graphs, and then that way we can talk about domain and range. So here's going to be my cute little parabola. This point of intersection is a -2. This point of intersection is 1, and the vertex is going to be at a half. Right? So if I talk about domain, domain is read just like you read. It's read from left to right. Okay? And then range is the odd duck. Range is read from the bottom up. Okay? So let's start with domain. And if I start on the left is over here, way over there. It's a -infinity. Not my job to put a boundary on infinity. And then when it gets to the 2's included. When I get to the 1, the 1's included. There's nothing that's undefined, so the domain is -infinity to +infinity, or all real numbers. The range, if we start at the bottom, this is the bottommost value, so the half is going to be included, and then they go forever up, so it's going to go to +infinity. So domain and range are actually kind of fun. not too complicated. Let's do our next example. So for example 2, this is going to be a graph. It's going to be the top half of a circle, right? It's going to look like this. This value is a -2, this value is a +2, and then this relevant y value is going to be a 1. And on all of these, we're just going to find domain and range. So my domain, remember I read left to right, is going to be a -2, it's included, to a +2, and it's included. My range is read from the bottom up. The bottom is 0, so it's going to go from 0 to 1. Pretty simple. All right, let me turn the page. For our third example, we're still finding domain and range. Okay, so this graph is a cool one. It's going to look kind of like this. The graph's going to come in here. This value is a -2. This is a +2, and that guy goes that way. All of this in the middle, there's nothing there, so therefore it's undefined. So then my domain is going to be, starting at the left, a -infinity to a -2 included, and then because I have a break in the domain, I do a U, and this is the Venn diagram symbol. It means union. Okay, so basically it would say I'm going to go from -infinity to a -2. I'm going to skip some space. I'm going to start again at 2, and I'm going to go to +infinity. All right, the union is important. It doesn't have a leg because it's a Venn diagram union, so it's just a cute little U. The range is going to be at the bottom. 0 is my bottom-most value. It's the x-axis, so it's 0, and then it's going to continue forever up. All right, I have a couple more examples. Example 4, I'm getting all kinds of colors in on this one. So let's have a cute little cubing function. Let's say it looks like this, and it's going to cross right there at 2, kind of like a lot of 2's these days. So if you'll notice on this one, it's just like the parabola we did. Nothing is undefined. So the x values, so they increase slowly, are going to go forever and ever. So my domain is going to be -infinity to +infinity. My y values, my range, my y values go forever down and forever up, so my range is going to be -infinity to +infinity. All right, I have one more example. It's the most complicated, but still not that bad. So it requires that you remember some vocabulary that we've seen in previous math courses. So at a -2, I'm going to have a vertical asymptote. And if you'll remember that for a vertical asymptote, the values are trying to get there, but they can't quite make it. On this one, it's a 2. Same thing, I'm going to have a vertical asymptote. So I have a vertical asymptote at x is a -2, and I have a vertical asymptote at x is equal to 2. Then I'm going to have a horizontal asymptote. This is a cool one. At y is equal to 3. Okay, and we'll talk about asymptotes more later. I'm going to have a curve in this section. I'm going to have a cool little curve in that section that goes through the origin, and then I'm going to have a curve in that little section. So the domain is a little bit more entertaining. So let's talk about our domain. Starting at the left, it goes from a -infinity to a -2. Now this time the -2 is not included, because with an asymptote, the graph is going to try to get there, but it's never going to quite get there, so therefore it will never reach fully the value of a -2. It starts again on the other side of the -2, and it goes to a +2, and then it starts again on the other side of the 2, and it goes to +infinity. So that's actually kind of cool. The range on this one, so remember when I drew the graph, I said that it went through the origin. The bottom value of my graph is -infinity, and it stops at 0 included. And that's it. Oh, I lied. I neglected these guys. My bad. So I'm going to start at 3, not included because it's a horizontal asymptote, and then it's going to go up to +infinity. Now we're done. All right, the next thing that we're going to talk about are a cool kind of graph, and they're called a piecewise function. Piecewise function. You may have seen these before, but we're going to do a little bit more with them this year. Not a lot, but a little bit. And then I'll show you how to graph these in your calculator when we're done. A piecewise function is just a collection of pieces, that's a C, of a function, okay? They usually look something like this. You often see brackets, and you'll see here's a curve, and it only works if x is less than 0. The other part of the graph, the other piece, so this is the first piece, this is the second piece, is going to be x is greater than or equal to 0. And I'm going to put a little number there. Has no mathematical relevance, but it's just going to help me talk about the two different graphs. All right? So that's what a piecewise function looks like. Now let's graph it. So to graph them, if you're doing it by hand, you need to have a handy-dandy pencil because we're going to do some erasing. So I'm going to start with this piece up here. This is a quadratic function. This is a cute little parabola that's been shifted up 1. So I'm going to put a 1, and I'm going to draw my parabola. And then I'm going to manage the condition. This says it's only a parabola if x is less than 0. So I'm going to put an open circle because it's not included on the 0. Less than goes to the left. And then I'm going to erase everything on the right. Okay? Now I'm going to manage this part. This is the y-intercept is a -1. It's just a cute little line. The slope is up 1 over 1. So I'm going to draw my line. And then I'm going to manage the condition. This said x has to be greater than or equal to 0. So that means though 0 is included. And then this part goes away because greater than or equal to goes to the right. So my graph actually looks like it's important to include the open and closed circles, and then it's this part that goes to the right. And I'll show you how to do those in your grapher in a moment. So now let's say I want to evaluate this function at f of a -1, f of 0, and f of 1. When you are evaluating a piecewise, P-I-E-C-E, each point of evaluation works only in one piece. It doesn't work in multiples. All right? So if we talk about f of a -1, a -1 isn't greater than or equal to 0. It only works in this one. So I'm going to put my little 1 down here so we know that we evaluated it in that first function. So then it's going to be a -1 quantity squared plus 1, and this is going to be 2. So f of a -1 is equal to 2. And if you looked at it, if I did this from the graph, here's a -1. F of a -1 is going to be somewhere up there, which could probably be about a 2. Kind of a crappy graph. All right, so the next one I want to evaluate is f of 0. Again, if we look at our conditions, 0 is not included on this one, but it is included on this one, which means that when I evaluate it, this is the piece that I'm going to use. So I'm going to put a little 2 there just so I know which equation I'm evaluating it in. And I'm going to do 0 minus 1 is a -1, so f of 0 is a -1. The next one that I want to evaluate is f of 1. Okay, and if I look back here, 1 is not less than 0, but 1 is greater than 0. So I'm going to, again, evaluate it in equation 2, and I'm going to have 1 minus 1, which is 0, and then I report nicely, and there's my 0. So when you are evaluating a piecewise function, you have to be really careful to make sure that you evaluate it only in one equation. So now let's go into our, get your handy dandy grapher, and we're going to, I'm going to delete this, clear, and this from other cool things. I'm going to show you how to graph a piecewise in your calculator. When you put these in your calculator, each piece has to be in parentheses, and then you're going to divide it by the condition. And yes, you can put inequality signs in your grapher. So I'm going to put my first equation, which is x squared plus 1, put it in parentheses. I'm going to divide it by the condition x. The condition lives in second test. Let me see if I can move my calculator up a wee bit so you can see it. So test is right here under your math button. And then I want to do less than 0, which is option number 5. I put in my 0. And then I'm going to put the second piece. So I'm going to do my x minus 1, divide by the condition x is second test, and then greater than or equal to 0 is option number 4. I put that in, close parentheses. I'm going to move this up a little bit now so you can see it, and I'm going to do a zoom 6. So here comes, there's the left-hand side of the parabola, and there's the right-hand side of the parabola. I just have crap on my calculator, so it's kind of messy looking. So I'll see if I can zoom it in a little bit. That's actually kind of cool looking. So as the graphs get more complicated, it will show you all of the individual pieces. All right, that is it for today. I will see you soon.